Hi, in this video, I'll be solving this question from the joint entrance examination from India. In India, the joint entrance exam is a highly competitive examination used by the country's top engineering and science universities for admissions purposes. And this question comes from the August 2021 administration. This question involves a function f that has a whole bunch of trig and inverse trig, and 4 inches choices that involves f prime. So sooner or later, we'll have to take the derivative of this. Well, before we just jump in and do it, let's think strategically. What these 4 answer choices tell us is that they want to balance between f prime here and the square of f here. We need to balance it using some coefficient in front so that the two of them either add to 0 or subtract to 0. Well, f is a big long expression, but at bottom line it's a cosine. So f squared is cosine squared. F prime, however, is a different story. F is a composition of a lot of functions. So if you're just going to go ahead and take the derivative, you will have layer upon layer of the chain rule. And each time you apply the chain rule, you end up with a product. And so you will also end up with layer upon layer of product rules. So even if you manage to take the derivative correctly that way, you will end up with something that's so long and so complicated that there's no way you can manage to balance it with the f squared, which is just cosine squared of all of this. So leaving f as is and taking the derivative of it is a bad idea. We should be simplifying this first. And so that makes this problem at bottom line a trigonometry question. Let's get going with this question. The function f has a combination of trig functions and inverse trig function. Each inverse trig is an angle, right? So there are 2 angles in this whole combination here. There's the cotangent inverse, that's one angle. And then there's the tangent inverse, that's another angle. And then there's 2 times that. For each angle, let's draw the right triangle for its definition. First, let's define the cotangent inverse as angle alpha. And in fact, let's split that square root of a fraction into a fraction of 2 square roots. Like this. So that means in a right triangle, if alpha is that corner, then this side is square root of x and the adjacent side is square root of 1 minus x. Then let's use Pythagorean theorem to calculate the hypotenuse. The square of the hypotenuse is the sum of the squares of the other 2 sides. So the hypotenuse is equal to 1. If that is alpha, and those are the sides, then that means we can go out 1 more level and get to the sine of this. Sine of alpha equals square root of x. Now let's go to tangent inverse. Tangent inverse, let's call that angle beta. And that means the angle beta is the tangent inverse of square root of x. Well, let's now draw a right triangle for tangent inverse. And the hypotenuse is square root of x plus 1. And our function fx is cosine of 2 times this angle. So we need 2 times beta. This is the part of the question that's actually hard, or at least for me. So what I do is I mentally go through all the double angle formulas to see which one helps. So in my head, I went through these formulas and I realized that even though our problem is basically cosine of 2 beta, these are not helpful, but this one is. Because then 2 times beta would be the arctangent of this expression, and it all consists of tangent of beta, and we know what tangent of beta is. Tangent of beta is equal to square root of x. So that's the helpful formula. That's the formula I will use. So tangent of 2 beta is equal to all of this. And since I know that tangent of beta is equal to square root of x from the previous step, I have all of this. That means that if I create a triangle again with the 2 beta angle in the corner, then I have 2 square root of x on the opposite and 1 minus x on the adjacent. Again, looking for the hypotenuse. And the square of the hypotenuse is a perfect square, so that's really nice. That means the hypotenuse is 1 plus x. And the question asks for cosine of 2 beta, so cosine it is. So I have simplified fx to this simple ratio. Now let's take care of the multiple choice. The multiple choice question basically says, how do I balance f of x squared with the derivative of f prime of x? So f of x squared is the square of this. Whereas the derivative of f using the quotient rule v u prime minus u v prime, the whole thing over v squared. Simplify the numerator. Okay, I have this fx squared and I have this f prime of x. And how do I make them balance out? Well, it looks like if I want to do that, then I need to multiply f prime by 1 minus x squared, and I multiply the square of f by 2. Then that way I have opposites. Then they would be canceling out. So it looks like if I multiply f prime by 1 minus x quantity squared, then I'll get the opposite of 2 times f of x squared. Therefore, the answer is choice A. Well, to be honest, I'm totally amazed at how they came up with this trig expression in the first place, but it's been a lot of fun solving it. Hope you had fun too. Any questions? Ask in the comments. Click like and share and subscribe for more contents. And thanks for watching. Bye.